I asked all of you guys to grab that half sheet of pink paper, These are your I can statements. These are your I can statements, right? So this is gonna, remember yesterday or on Friday, I asked you to skip a page in your journal. This is where you're gonna put your I can statements. So that first box is our I can statement. What is the I can statement for lesson 2.2? Owen.
I can evaluate a function for a given value using function notation.
Yes, I can evaluate a function for a given value using function notation. This is right off of your I can statements. Right off of your I can statements. This is your I can statement for 2.2. I can evaluate a function for a given value using function notation. You guys are looking at your 2.2 I can statement. Raise your hand if you need more time with that. I see you. Ms. Kenner, you good? Okay. Alrighty. So function notation is written like this. We read this as f of x. That's how we say this. We say f of x. F is the name of the function and x is the input. When we use function notation, this is no different. This is no different than if you saw y equals x squared. It means the same thing. It means the exact same thing. So we evaluate it the exact same way. So for each of the following functions, we have to find the outputs given the inputs. So example 1a, our function f of x equals 3 times x plus 7. So when it's asking you to evaluate f of 2, we read this as f of 2. This just means, this is an easy way of saying let x equal 2. It saves a little bit of space on your paper. You don't have to write that, okay? That's what that means. So essentially, we're going to take this function, 3x plus 7, and we're going to replace the x with a 2. That's all we're doing. So 3 times 2 plus 7, well, that's 6 plus 7. So the only difference is when you write your final answer, how did you evaluate this function? You evaluated this function for f of 2, and f of 2 equals 13. F of 2 equals 13. Let's take a look at the second example. So this is f of negative 3. That's how we say that. This is the same thing as saying let x equal negative 3. And you don't have to write this every time. Remember, this is just a note or a journal, so I want you to really know what it means. So I'm going to take negative 3 and plug it in to the function 3x plus 7. So I'm replacing the x with a negative 3. So let's see. What is 3 times negative 3? So I have negative 9 plus 7. And what is negative 9 plus 7? Okay. So we write f of negative 3 equals negative 2. And again, it's really important to make sure that's how you write your final answer. You have to write it as whatever you evaluated the function for. So f of negative 3 equals negative 2. Questions? What are you thinking, Owen?
I'm not thinking anything.
Okay. I just want to make sure does this make sense?
It does.
Okay. Okay. Let's look at example B. Example B. So this is the function g of x. G of x equals x minus 6. The quantity is divided by 2. So we have to evaluate g of 20. G of 20. So that means I'm taking the function x minus 6 divided by 2, and I'm replacing the x with what? 20. 20 minus 6 divided by 2. Well, what is 20 minus 6?
14.
20 minus 6 is 14, and 14 divided by 2 is 7. So we write g of 20 equals 7. G of 20 equals 7. Does this make sense, guys and gals? Okay. What about g of 0? Let's do g of 0. So same function, x minus 6 divided by 2. I'm using the g. This right here tells me that I'm evaluating the g function. That's what this tells me. So I replace the x with a 0. So I have 0 minus 6 divided by 2. Well, what is 0 take away 6? Negative 6. Good job. And negative 6 divided by 2 is? So g of 0 equals negative 3. G of 0 equals negative 3. Does any of this seem disturbing to you, or do you feel okay with it? All right, raise your hand if you need more time with that. Okay, I'm going to keep on going. So example number 2 says a function is defined using the following formula. F of x equals x over 3 plus 7. It says explain what the function rule does to convert your input, x, remember that x is your input, into an output, f of x. So what is happening to x? This is no different than looking at an equation that we solve for x, and we say what's happening to x. So that's really what this is asking. It's saying what is happening to x. That's the question. So what is happening to x? What are we doing to the input x? What do you think, Ken? What's happening to the input x? It's being divided by what? So we're going to divide it by 3. And then what? That's exactly right. Good job. And then add 7. That's what the rule is saying. Take your input, divide it by 3, and then add 7. You're going to take your input, divide it by 3, and then add 7. So when I look at example B, it says you have to evaluate f of 6 and f of negative 9. Remember, we're using the function f of x equals x divided by 3 plus 7. So when we evaluate f of 6, we can say that f of 6 equals, I replace the x with a 6. So 6 divided by 3 plus 7. Well, what is 6 divided by 3? It's 2. So this equals 2 plus 7. And what is 2 plus 7? 9. Am I good like that, or do I have to do something else? Is that an acceptable answer? What's the matter with Owen?
It hasn't been fully, I guess, like simplified.
What do you mean by that? I'm just missing something. One thing. What am I missing at the beginning of that? Kenna. Yeah. And what is the f of, what did we evaluate this at? We evaluated this at f of 6. Yes. I need to have that as my final answer. You have to put that in there, okay? You have to put that in there. It's no different than when you solve for the variable x or y or z. You put z equals x equals y equals whatever, kind of the same concept. So now let's evaluate f of negative 9. So f of negative 9 equals, remember I'm replacing the x with a negative 9. So negative 9 divided by 3 plus 7. What is negative 9 divided by 3?
That is 2, negative 3.
So negative 3 plus 7 is?
Negative 10.
Negative 3 plus 7 is what?
No, it's positive 4, right?
Good job. Yes. Nice job, Kylie. So f of negative 9 equals 4. F of negative 9 equals 4. That just says when you let x equal 9, your output is 4. When x is 9, your output is 4. Okay? So question C says, what two coordinates, remember that coordinates are x and y, but I just told you that f of x and y are the same thing. So I'm looking for the ordered pair x and f of x because that represents my output. That's the ordered pair I'm looking for. So based on the two functions, or well, the one function with the two inputs that we just evaluated, what did we let x equal in the first evaluation?
We let it equal 6.
And when x is 6, what is your output, f of x? When x is 6, what do you get as your output? Lissandro? 9. That's our first ordered pair. Remember that this is your output. This is your input. Okay. Does someone see another ordered pair that we have from the work that we did above? What was our other input value from above? What else did we input?
We input negative 9 and 4.
Yeah, we input a negative 9 and we got out a 4. Negative 9 is my input. Positive 4 is my output. So we can write those as ordered pairs. So the two ordered pairs from the work that we did in example B are the ordered pairs 6, 9 and negative 9, 4. Okay. So g of x is another function. And g of x is made by taking 2 times the f of x function and then subtracting 1. Whew. Okay, so let's look at that. I know that g of x equals 2 times the f of x function And then we have to subtract 1 from it. Well, what was f of x? What was the f of x function that we evaluated up top? F of x equals what? Look at example A. What did it tell us f of x was? Go ahead, sir.
You mean me?
Yes, sir. Owen, sorry.
Okay, 6, 9.
No, look at the actual function rule. I want you to look at the function rule right here.
Okay,
So what's the rule? F of x is what rule?
f of x equals x over 3 plus 7.
So we're going to take 2 times that rule. 2 times that rule. So 2 times x divided by 3 plus 7. Okay. So we can do one of two things. We can simplify that, or we can just evaluate it because it says that g of x equals 2 times the f of x function, which is x divided by 3 plus 7. Subtract 1 from that total. Well, we're trying to evaluate g of 6. So all we're going to do is replace the what with a 6?
The x.
Yeah, we're just replacing the x. So I have 2 bracket 6 over 3 plus 7. Whoops. I want that to be a bracket. And then that quantity, subtract 1. So let's simplify. Order of operations says we have to simplify the parentheses first. So what's happening inside that bracket, that grouping? What is 6 divided by 3?
2.
2. So I have 2 plus 7 minus 1. So what is 2 plus 7? 9. So now I have 2 times the quantity of 9 minus 1. What is 2 times 9?
18.
So g of 6 equals 18 minus 1. And can I simplify it one more?
Yep. To 17.
So g of 6 equals 17. G of 6 equals 17. Okay? That one's scary. Okay? We'll put a little star by that one. I'll come up with a practice one like that. What about example E? What about example E? This one is different. It says, hey, you need to find the input. You need to tell me what value of x gives you an output of 12. So let's see. Our f of x function is x divided by 3 plus 7. Well, if f of x equals 12, I can just replace the whole f of x. I'm going to take this whole f of x and replace it with a 12 and solve the equation. So f of x is 12. So 12 equals x divided by 3 plus 7. Because we're trying to solve for x. We need to know what our input is. So if we're trying to find the input or solve for x, what would I do first?
You would subtract the 7.
Yes, sir. I would subtract 7 from both sides. Absolutely. So I have 5 equals x divided by 3. What would I do next?
Then you divide 5. Right?
How do I get rid of a divide by 3? What's the inverse or the opposite of divide by 3?
You multiply
Multiply. And whatever I multiply by on one side, I have to do on the
the other side.
good job. So I find out that 15 equals x. So f of what equals 12? F of 15 equals 12. So this one we had to find the input. We were given the output. still have the same rule, the same function rule, but we had to find the input. What X value gives you an output of 12, okay? I want everyone to grab their calculators because you get to use a calculator, right? So I want everyone to grab a calculator. Yeah, remember they're in your buckets in front. We did that test on Friday. I want you guys all to go to the y equals. I want everyone to go to the y equals. First gray button up at the top. Y equals. Turn on your calculator and press the button y equals. Y equals. And we're going to input this function rule. We're going to input this function rule right here. So we're going to press the button y equals and we're going to put in the equation. And if you already have an equation in there, just hit the clear. Hit your clear button. Okay, so y, hit clear, clear it out. There's an equation in there, clear it out. So our function rule is x. Here's your x button. Your x button is right here, pointing to it. Your x button is right here. Does everybody see the x button? It's this button right here. Okay, so we're going to hit x divided by 3. I'm coming to check your calculators. X divided by 3 plus 7. I'm coming to look at everybody's calculator. X divided by 3 plus 7. X is right here. X divided by 3 plus 7. You have x minus 3. So let's clear that out. X divided by 3 plus 7. Okay. Awesome. I'm going to show you a trick. This is a trick that you will want to use all of the time. You got yours, Tim? Okay. Daniel? Okay. All right, so let me tell you what. Your calculator will make a table of values for you. Your calculator will make a table of values for you. So the way that it does this is you guys have a gray button that says graph. And right above that, in little tiny words in blue, it says table. And that's what we want. We want the table. So we're going to hit the second button, which is your blue button, because we want to use all the little tiny words. So we're going to hit the second button and then the graph button. Second, graph. And it's going to give you a table. Okay? Yeah. So remember that f of x is the same thing as y. So I want you guys to arrow down to where you see an output of 12.
So where's the?
You want to clear out that So listen to what I asked you to do. I want you to arrow up and down. You're looking for a y, which is your output. You're looking for a y value of 12. When do you get an output of 12? When your input is what? 15. How nice is that? Okay? How nice is that? So your calculator understands function rules. All right? It is magic. Okay. We're almost done. Almost done. Move over to the question number 3. Question number 3. Boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature T is a function of the number of hours. So it's a function of time. So some things that I want you to notice in the table. Notice when I first take my boiling water off the burner, stove, whatever, time is 0 and the temperature is 212. That's where we started. After 1 hour, the temperature went down to what? 141. After 2 hours, the temperature was? Okay, so that's how we read the table. So it says evaluate T of 2, meaning this is the same thing as saying, what is the temp at 2 hours? That's what this is saying. What is the temp at 2 hours? So go to 2, your input of 2. When you have an input of 2, Tim, what is your output? And it's degrees Fahrenheit. So 104 degrees Fahrenheit. This T of 6 is saying, hey, what is the temp at 6 hours? And again, I'm writing this out because I want you to know what it's really asking you. What is the temperature at 6 hours? So T of 6 is what? I heard someone just say it. Yeah, good job, Kylie. It's 68 degrees Fahrenheit. T of 6 is 68 degrees Fahrenheit. So after 6 hours, the temperature is 68 degrees Fahrenheit. Okay, we got some crazy stuff going on here. Sorry. All right. So question B says, for what value of H, remember H is your input. H is your input right here. These are your inputs. These are what you get out. Okay. So for what value of H is T of H 76? So that's the same thing as saying after how many hours is the temperature 76? Yeah, I'm going to write that down though. You are exactly correct. After how many hours is the temp 76 degrees? And Kenneth said after 4 hours. So T of 4 equals 76. So H equals 4. Does this make sense how we're looking at the table? All right, Victoria, I'm coming to you for the next one. It says find the value of T of 8 minus T of 0. So we're trying to find the temperature after 8 hours. What is the temperature after 8 hours? Victoria, what's the temperature after 8 hours? 65 minus the temperature at 0 hours. 212. So what is 65 minus 212? 65 minus 212. You can use your calculator. Negative 147 degrees Fahrenheit. So it says use appropriate units and give interpretation of this answer in terms of the problem. So that just means how many hours have passed? How many hours have passed from 8 to 0? Like how, when I first started, time 0 to 8 hours, it's just 8 hours. So here's what it means. After 8 hours, the temp, is it, because it's negative, what does that mean about the temperature? Is it going up or is it going down? Because our final answer is negative, is the temperature going up or going down, Owen?
Down.
It's going down. After 8 hours, the temp dropped, or decreased if you want, 147 degrees Fahrenheit. That's what happened. After 8 hours, the temperature dropped 147 degrees Fahrenheit. After 8 hours, the temperature dropped 147 degrees Fahrenheit. Okay, this next one, I'm looking at this right here. This is a typo, not a typo. This is a transforming from a Word to a PDF kind of formula error. So I want to fix this really fast. So I'm going to scribble this out. This is saying the function y equals f of x. That's what that's saying. The function y equals f of x. So I'm going to wait for everyone to fix that. The function y equals f of x is defined by the graph shown below. So we're going to look at this graph. We're going to look at this graph, and we're going to answer questions based off of a graph. So let's see. I just want to recap really fast. We answered questions using function rules, right? F of x and g of x, just plugging it in. We just answered a bunch of questions using a table, and now we're going to answer a bunch of questions about f of x using a graph. Now we're going to answer a bunch of questions about f of x using a graph. So question A says, hey, evaluate each of the following. F of 2. So when my input is 2, let's go to where x is positive 2. What is my output? It's 9. Who said that? Good job, Kylie. When my input is 5, when I let x equal 5, what is my output? Owen?
6.
Good job. Brianna, I'm coming to you. When my input is -3, when my input is -3, what is my output? So here's -3, -1, 2, 3. What is my output? Y equals what? Or f of x is what? What spot is this on the y-axis? So this is 0, 1, 2, 3, 4, 5, or 0, -1, -2, -3, -4, -5. This is a -5. So when I let x equal -3, my output is -1. When x is -3, my output is -1. Avery, what about when I let x equal 7? F of 7. When x is 7, what is your output? Where is this touching on the y-axis? Say that again. You said it right. On the 0. F of 7 equals 0. So this is the ordered pair 7, 0. When I input a 7, I get out a 0. This is the ordered pair -3, -1. So when I input a -3, I get out a -1. This is the ordered pair 5, 6. When I input a 5, I get out a 6. This is the ordered pair 2, 9. When I input a 2, I get out a 9. Does that make sense how we're reading those ordered pairs and using those to answer how to evaluate a function? Okay. So now we're going to do it in reverse. So this is telling you that your output equals 3. This says, hey, your output equals 3. So let's take a look at, I'm going to erase this. Let's take a look at our x and y-axes. So our output is the y-axis. So what input value gives you an output of 3? What input value gives you an output of 3? There are 2 of them. When x is -1 and when x is 6. There are 2 of them. When x is -1 and when x is 6. So if x is -1 and when x is 6, you get an output of +3. There are 2 possible answers. Two possible answers. What about when my output is 7? What about when my output equals 7? So I'm looking for anything that touches this line. Anything that touches this line. So what about when my output is 7? What are my inputs? What x values did I use to get an output of 7? Well, when x is what? Are we following? What input value gives you an output of 7? X is 1. What other input value gives you an output of 7? 4. Okay. Question C is talking about the domain and the range. Question C talks about the domain and the range. So tell me what the domain is.
Input values.
Yes, remember that the domain is the input, also known as x's, and our range is what? Our range is the output, also known as the y or f of x. Okay, so we're going to look at the range. So my x values run from here all the way to here. And because this is a filled in circle, it means that this x value is included. And because this is a filled in circle, it means this x value is included as well. So this graph runs from what to what? What's the smallest it runs from?
-4.
Good job. And what's the largest it goes to? 9. We have to write this as a set. So we're going to use that little squiggly bracket and we write x such that, so you said it went from -4 to 9. So we're going to write it as an inequality. -4 is less than or equal to x is less than or equal to 9, meaning that the domain points, any input value is going to be in between -4 and -9, including -4 and 9. So we say it's between -4 and -9, or -4 and +9 inclusive. That's why we use the equal sign with the inequalities. -4 is less than or equal to. Okay, if there had been an open circle on one of those, then we would have had to change the way we wrote our inequality. Let's talk about the output value or the range. What is the lowest our graph goes? Well, the lowest our graph goes is right here. And what's the highest our graph goes? Right here. So, Aiden, what is the smallest y value? What is the smallest y value? You're what? Okay, so look up at the board. Where am I pointing? This is the lowest point of the graph. Where does it hit on the y-axis? -3. And what is the highest y value? Look at the very top where I have it highlighted in purple. What's the highest it goes up? Y value, not x value, y value. What is the y value? 9. So this goes all the way up to 9. So same concept. We're going to write it in set notation. So y such that my smallest is -3 and my largest is 9. So -3 is less than or equal to y is less than or equal to 9. -3 is less than or equal to y is less than or equal to